Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, and welcome to AI for Good, a webinar series by the International Telecommunications Union, the ITU. My name is Jennifer Woodard. I'm an AI entrepreneur and co-founder of Insikt Intelligence, a machine learning startup focusing on the detection and defeat of online harms. We are very happy to have you here today for what I know will be an exciting discussion about a topic that touches each and every one of us on a personal level every day, and that's cybersecurity. From malware to hacking to phishing and so many other threats, cybersecurity is not only a growing problem, but a booming industry. And while many advances have been made over the past few decades, the growth of threats and their changing nature require new tools and technologies to keep up with the bad guys. And this is where AI, and AI for Good specifically, comes in. We're here to talk about how AI can enable the future of cybersecurity and its roles in detecting, mitigating, and responding to cyber threats and attacks. To discuss this fascinating topic, we have two distinguished speakers from one of the world's biggest names in cybersecurity, Avast. Joining us today is Jaya Baloo, Chief Information Security Officer, and Andrew Gardner, Vice President of Research and AI. Jaya Baloo is Avast CISO and joined Avast in 2019. Previously, she held the position of CISO at KPN, the largest telecommunications carrier in the Netherlands, where she established and led its world-leading security team. Prior to this, Jaya also held the position of practice lead of lawful interception at Verizon. She is formally recognized within the list of 100 CISOs globally and ranks among the top 100 security influencers worldwide. Jaya has been working in the field of information security with a focus on secure network architecture for over 20 years. Andrew Gardner is the Vice President of Research and AI at Avast. He is an experienced technical leader in AI, data science, and technology. Most recently, he worked at Symantec, but has spent time in clinical, academic, and enterprise roles. His passions are inspiring people, storytelling, and building great AI products. And he says that his favorite and most challenging AI is his 2-year-old daughter, Samantha. Jaya and Andrew will be sharing their visions with us. And after the presentation, we'll open up the floor to Q&A. So please have your questions ready. Jaya and Andrew, welcome to AI for Good. It's a pleasure to have you with us here today.
Thanks, Jennifer. Let me pop my screen up. Make sure we can see it. So first of all, let me say thank you for inviting me. This is an honor. I love speaking at events like this, and I'm excited to see what kinds of discussions ensue afterwards. I'm going to co-present today with Jaya. She and I are colleagues at Avast, and we threw this together, and hopefully I'll be able to touch a little bit on the AI part, and she'll be able to back me up with a lot of the security part, and we'll have a good discussion. When I was putting this presentation together, I was thinking about, I like to lead with provocative or interesting images, and I thought, well, why not see what we could just generate in a couple of minutes online? So I went to the service Crayon and typed in robot magician doing AI, and this is one that came up. I kind of like it because he's a gray hat, which is kind of interesting because certainly AI exists in the realm of the gray today. It can do good things and it can do not good things. And of course, we're interested in the good. But this is just an example of how AI has really flourished in the last few years. So it's so accessible to everyone who has an internet connection. And that really begs the question to think about, well, there's great things that AI can do. There are great things that we can create, but is it also able to help protect us online? I think over the last 10 years, we've experienced, a lot of us in the front lines, and many of us just through consumer applications and things that we may or may not be aware of, this idea of the AI manifest destiny. where we want to AI-ify the world. And this is causing us to enter a new golden age of AI. And I think, let me comment on the golden age part. A famous Stanford professor, Andrew Ng, he's a very influential figure in deep learning and AI, has likened AI to electrification. And I think that's a good analogy. In the US, when we started electrification, that process took between decades and 100 years, depending on when you start the clock. And what happened is each pivotal age in electrification of the US, you had a new technology or a new perspective or a new feature or a new deployment, which sort of changed the landscape. And I think we're facing the same golden age in AI. I'd say probably for the last 10 years, AI has been really accessible to experts and practitioners, and even available to consumers through things like voice recognition technologies in our smartphones, or image manipulation, or movie or game effects. Whenever we get a new tool or technology, it's very natural for people to do this, adopt this this manifest destiny kind of approach, which is the technology is great, it's going to help everybody, and it's so amazing we should deploy it as quickly and broadly as possible. No speed bumps, because unlike every other previous technology and the problems that came along, we don't need to worry about those. This one's different. I think that's clearly not the case with AI. A lot of people are aware of the potential risks, and I think that's something that's being baked into how we're deploying this. But we need to keep that in mind as we pursue this destiny. In addition to sort of the broader industry and the view of manifesting AI everywhere, in the security space, I also hear a few additional ones that I like to point out. Number 4, AI machine learning gives us new magic powers for free is one of my favorites. Even amongst seasoned AI practitioners, there's sort of an expectation that all the hard problems that we face, how do we stop something? How do we detect something? How do we enable a feature that we've been struggling with might somehow be unblocked with AI? And it's simply not true. AI and machine learning is all about automation and scaling. That's kind of a view that's popular in the security space also, because we have this pressure to be able to respond with increasing scale and velocity. And I won't say that it's not a correct assertion, but I think there's more to the story than just that. More data will make it better. This is something that everybody talks about in other industries. And there's this rush to try to get more data and different types of data and bring it together. There, again, is some truth to this more data will make it better story, but as we'll see in a later slide, it's a little more complicated than just more data. We need things in addition to more data. The last one is something that came up when I used to give talks in industry and enterprise security. People would often have an opinion they share with me and probatively to find out whether I thought AI and ML tilted the game in the favor of the good guys or in the favor of the bad guys. And so I was surprised to find that there are camps that believe in both. I have an opinion I'll share at the end, maybe in comments, but while we're going through the talk, just think about that a little bit and see if you have a perspective. I like to give a little context, so I want to talk to some of those who might not know about AI. How did we get here and why it's so topical? And this is my perspective. For those of you who haven't seen it before, I think it's a fair perspective, but it might be a little unique. You might not have seen other places. So I'll start with the 1950s to the 2000s. AI has been around forever. We just didn't know about it, really. We didn't experience it in our daily lives. And then in 2006, 2 magic things happened, which set us on this course where AI is in our daily lives now. The first was the invention of a technology called deep learning. You probably all heard about it. This is the fundamental driver of modern AI. Pretty much all modern AI systems rely in some form or another on deep learning because, quite simply, it's given us new capabilities and performance. The second thing that I put up there is the Netflix prize. Netflix was in the business of making movie recommendations. In 2006, they even still mailed DVDs to people. And the business economics and drivers indicated that the better recommendation Netflix could make, the better margin and satisfaction they could have for their business. So they created a crowdsourced contest called the Netflix Prize with a $1 million prize to try to improve the recommender system. And the reason I put it here is because this was the first large-scale, widely broadcast application of a commercial use of AI machine learning, and that was the development of better recommender systems. And of course, nowadays, we all experience recommender systems through every kind of social media or shopping site that we go to. That's how we find products and content to serve. So this is very fundamental and transformative. After the invention of deep learning, we kind of spent a few years tooling up, and this technology diffused across different industries. The number of researchers and students grew. And in 2012, we had sort of another watershed event, and this is called Imagenet. Imagenet is the name of a model that was used in a computer vision contest between academic professionals. These professionals were experts in the domain who would meet every year and have these benchmark shootouts and the ability to detect and classify images. And for the few years leading up to 2012, they had pretty much stalled at the efficacy performance. What was so amazing and what caught everybody's attention is that a grad student at the University of Toronto, Alex Krzyzewski, created this model. He wasn't an expert in computer vision, and he only spent months on this, and he entered it and crushed the competition. And this very model became the basis for modern deep learning systems that are able to achieve this magic 98% level of accuracy in a lot of perceptual AI challenges. 98% is an important number because, again, AI has been around since the 1950s, but we haven't really cared about it or seen it in our products. Lots of reasons for that, but one of the biggest ones is because it simply wasn't good enough to be usable. Imagine a spell checker that only gets half the words right. You're never going to use it. It turns out that, with some asterisks here, you need about 98% for people to want to interact with systems that are heavily AI dependent in a perceptual fashion. So in 2012, we had this sudden interest across academia and industry, the recognition that we had this ability to deliver state-of-the-art performance to create new capabilities. Also in 2012, we were starting to really hit stride with big data, and big data is sort of the fuel for AI machine learning. And what happened is over the next few years, in the next decade, we basically invented new applications and new technologies that further advanced capabilities of AI. And that's what most of these bullets are. They're techniques or applications. The two things I'll call out in green are generative AI and AI systems. And this is sort of the broad brushstroke of focus area that's been unfolding in AI most recently. In generative AI, what we're talking about is the ability of AI to create text or images or video or other content that's realistic or synthetic data. And often it can do this in a very natural human language interaction kind of fashion. So for instance, I could say, create an avatar named Anna and have her host the introductions for AI for Good. And I would have something like what we saw earlier. The second one in green is AI systems. And this is sort of the recognition that we have really gotten really far ahead on the techniques, but what we need is better products or systems that are able to consume robustly end-to-end the data all the way through to the applications and artifacts that we deliver. And this is an area, if you're in the space, you might have heard about with like MLOps and other operations-oriented things designed to create these big scalable systems. Lastly, I don't want to forget about self-driving cars. I used to open my talks with self-driving cars, but they seem to be forever away. In 2014, for those of you who might remember, Elon Musk promised us that we would have fully autonomous self-driving cars the next year. That's 2015. And he's been promising that every year. So keep your fingers crossed. Maybe we'll have one in 2023. Now, we all read about AI and we see it. You can go online like I did and create an image or a video or a deep fake or some text, etc. And so it seems like AI is everywhere, and it kind of is. But the advances that are so science fiction haven't seemed to hit the cybersecurity industry as strongly. And I think there's a reason for this, and I want to call it out because it's important that we understand this so that we can look at this root cause and try to bridge that gap and do some technology translation or some invention and research in our industry to help overcome that. I have several bullets here. I won't go through them all, but I'll call out a couple. The first one is our data in cybersecurity tends to be different than cats and dogs. I can't just look at an image and say if this is a good file or a bad file for a log. Even if I thought it was a bad log file, what does that mean? Does that mean something in the log file was bad? Or does that mean the log file itself was bad? Or does that mean that it could be bad? This is just the tip of the iceberg for the types of problems that we have in terms of representing our data. It's complex, it's sequential, it's relational, it's expensive to get labels. Oftentimes it's hard to understand. So this is a barrier which limits the velocity with which our human researchers and security experts can make progress in AI and do this technology transfer, like taking things from the computer vision or NLP community and bring them to cybersecurity. The second one I want to call out is the complicated decisions that we face. So again, because things aren't always black and white in security, right? So something that might be borderline gray or malicious to you might not be borderline gray or malicious to me. Things that I've declared to be clean might not actually be clean. Maybe they just haven't detonated yet. The costs between false positives and false negatives, time to detect, and overall protection, these are complicated. And I think they're a little more complicated sometimes than the images, right? An image, it's sort of, you got the thing or you didn't get the thing. There's a cat in the picture or there's not a cat in the picture. I don't want to oversimplify. I mean, image processing, computer vision is very sophisticated too, but I think maybe our understanding of this complicated decision process is not as mature in the cybersecurity space. So it makes it harder for us to frame our initiatives and our projects and our products as clearly. The last one I want to call out is the understandability and collaboration. So we have closed communities, and there's a little bit of healthy rivalry, even bordering sometimes on adversarialness between different communities within the cybersecurity space. So for instance, I lead research labs, and security researchers and AI researchers and scientists and engineers oftentimes have very different perspectives, and they don't fully understand each other's perspectives. And oftentimes they can get in pretty heated debates about it. So I think that the collaboration is something that we can improve and to accelerate the velocity of our progress in the cybersecurity space. All of this just means that we're a little slow compared to, videos detecting cats and other things on the web. Because of these challenges, a lot of the cybersecurity space focuses on building what I call yet another threat detector. These are kind of obvious and incremental. These are things where we'll take an existing problem and try to improve the efficacy, for instance, by reducing the false positive alerts or the false negatives or things like that. Or perhaps sometimes we'll look at it and we'll throw in a new technique or enrich it with some new data, or maybe we'll solve a slightly adjacent problem. There's nothing wrong with this. This is a very noble bit of work, and this is required to keep our cybersecurity automation detection systems going. But this isn't the stuff that's going to be the breakthrough that allows us to really do the good that we want to do in cybersecurity and really totally rethink the way that we can protect people and totally provide new capabilities. For that, we need to go to and do a deep analysis of cybersecurity and AI. By the way, it's not just AI. This is an AI talk, but there's many other things that play into successful cybersecurity solutions. I've got a list here on the left. I won't clear the whole slide. I'll focus us a little bit. But on the left, things that might be more traditional views on how we approach security or cybersecurity, and on the right, things that we might reframe those two with the context of AI in our mind. And I'll just call 2 or 3 out. The first one's up on the left, and I'll speak from my personal experience, even as a user and an employee of a company, et cetera, is this idea that security should be all about denying and locking down channels and access points and devices. And this is very rigid, and it's the idea that if I lock everything down and only permit things that have special requests that I can assess, I can protect you. What we found out with AI is, now that AI is everywhere, we can't always anticipate things that'll happen with AI. There's lots of unanticipated consequences. Also, it's very not user-friendly to be locking things down all the time. So what I think we need to have, and what we're seeing a little bit about, is a little more flexible perspective on how we think about cybersecurity interacting with the user. But we need to understand, have the applications, systems, and policies understand what users are trying to do at the time they're trying to do it, and do the right thing for the user, right? And accept that there are going to be some mistakes and a lot of unknowns there, and build the systems and support that will enable us to deal with that. Also, as part of this, instead of focusing on devices and channels, and we shouldn't forget about devices and channels and access points, but we need to broaden our thinking and consider more about human interaction, messaging, and our cognitive focus. Just in a typical workday, just imagine how many times you switch between different emails, video conferences, texts, in-person meetings, devices in your company or home office, and how you do this across your phone, maybe your watch, your laptop, etc. So this is a much more complicated digital life that we lead. It's more about the transactions and interactions. And the weak point there is also because of the interactions, right? How do we know that we're operating with someone on the other side, AI or human, safely? How do we know that they are who they say they are? So this is the kind of thinking that we have to focus on. The next one I want to talk about is scaling with more data versus scaling with better engineering and ops. So of course, more data can be good. It's not just data. We want good data. That means data that has signals or information content that's useful. So that's a great thing to go for. And if you have a company or a business or personally you have access to that, that's amazing. But what we're finding in the industry as a whole, not just cybersecurity, but like the whole AI industry, is that part of the key to success of AI and adoption here is being able to scale with better engineering and ops. How can we build and deploy applications and systems robustly end-to-end, track them and monitor them, just like software applications at web scale? This is where a lot of breakthroughs are happening, and I think that we should think about in cybersecurity space, because being able to process these systems at speed and scale is how we're going to be able to continue to do good and create new capabilities. The last one I want to share is one that surprised me when I first learned about it, and often surprises people in the industry. which is the old way of thinking, and the way that if you're an insider, you might think about protecting people is efficacy. Basically, how many attacks did I stop, and at what cost of good things that I had to block, right? False positives and false negatives. And what I always tell people on my team is efficacy doesn't sell. And that's surprising. And what I mean by that is when you go talk to, say, customers, for instance, in an enterprise context, or you think about users, everybody expects security work. They expect efficacy. They expect it to be really good. And they expect everybody who's a contender to provide comparable levels of efficacy. And they don't believe what you say about your numbers. So instead of thinking about the efficacy, that's a given. We have to do it. What I think we need to do is broaden our perspective and ask ourselves as providers of this, what are the kinds of decisions that we need to endow our cybersecurity products with so that people can make better choices and be protected? What features are needed in the market to protect people in these new contexts that are not just device or channel centric, but messages or interactions or websites or social networks, et cetera? And what does the market say about investing, right? And by that, for instance, I mean, instead of protecting Windows 95 machines, which might be very important in an industrial control systems kind of context, maybe we need to think about protecting smartphones more, right? I want to switch now and show a couple of case studies and some examples, a high level of how AI can help us make progress, so you can get a feel for it. So these case studies are on representations. And in AI, what we think about, we talked about data as a challenge for cybersecurity and AI. And one of the challenges in the data is how do we represent things? Okay, fundamentally, AI, the engines, the algorithms, if you will, they expect tables or lists of numbers that are the fixed length or fixed size. We call them vectors or arrays. And that's not the nature of data in the real world in cybersecurity. Often what we have are things like JSON or other hierarchical structured data. In fact, as much as 80 or 90% of the web traffic is brokered in JSON. JSON is a human readable text format that has a hierarchy to it. And you can see example right here. And the problem that we have with the JSON data and using it in AI is they're typically in traditional AI is not a good way to encode that data to get a regular vector or matrix that can be consumed. We call this the representation problem. These things can be jagged, or you can have multiple repeated elements. And normally in AI, we don't really have the capability to handle that. So we've created a technology to Avast, and there are similar technologies that are out there on the web to handle this. This is called the hierarchical multiple instance learning problem, fancy words for what I'm talking about with the jagged and repeated elements issue. And we can use this to create a representation so that AI can do its magic at classifying examples. And then once we have classifications, we can take the results back and go point to the places in the data stream that we attribute to the decision so that we can provide some understanding. And this opens up and unlocks a whole new class of data for us to use, for instance, Avast, for instance, log file analysis, web traffic analysis, et cetera, so that we can provide better protection in new areas we wouldn't typically be able to create models for. On the right-hand side, I'm showing an example of structured code as strings. So for instance, sorry, go back. When you learn about AI and machine learning and you are a security person or vice versa, the first thing you try to do is think about, oh, I'm going to build a detector that's going to classify malicious files. And a file, a binary file that you download is basically a string. And what people try to do is they try to lay it out in some two-dimensional format so that you can run computer vision algorithms, because we read in Wired magazine and other places about all these amazing capabilities of computer vision for AI. Now, it's not an entirely bad idea, and I'm showing an example here. You can see in the blue and cyan some hex dumps of some characters from files that are normal or encrypted, and you can just basically take away that they're different. So you can imagine that the machine learning algorithms, the AI, could learn something about that and actually point to where in the file things are good or bad. But in order to make even more progress on this, you really have to throw in a lot of extra learning techniques in this. For instance, if you look at the way humans do this, by the way, there's an interesting study we did where a malware analyst can actually open up in a hex editor these files and see just characters and strings like you see in the blue and cyan. And in a few seconds can classify a file as good or bad, almost as good as state-of-the-art systems. That's just amazing, because a few seconds isn't really enough time to go through the whole file and do any deep thinking. We did this study to understand so we can improve our AI and incorporate the ideas there. And so what they're doing is they're actually using a phenomenon we know in psychology called chunking, and recognizing different regions in the file that change their texture or characteristics. And then based on that, sort of accumulating some evidence like, that one looks kind of good, this one looks kind of bad, et cetera. and then putting it all together into decision. And so by looking at how humans solve these problems on these structured code strings, we can take that and transfer some of that approach into our traditional deep learning or AI pipelines and build better detectors. This is all about representations and understanding the natural format of data and how to map that to something that machine learning can use, and what kind of tricks we can include along the way. Here's another example that we have, and this one's a little bit science fiction-esque in the sense that this doesn't exist today as a whole product, but in parts. And so I'm sure many different companies are working on this, and we work on this too. But the idea is that when you go to a phishing or a scam website, something that's designed to visually fool you, or at least provide evidence to visually fool you and social engineer you, what we do today is we take something like a bank A, and we look at the screenshot of that, if you will, or something like a form on that, and compare it to a database of known banks that we have, find the closest matches and say, well, does this look close enough, and is it phishing or not? And there's nothing exactly wrong with that. It's just it doesn't scale, because we have to go maintain this database of all of these banks, and then we have to define what close looks like, et cetera. And at the end of the day, the screenshot as a whole isn't necessarily what fools you. What fools you is the page as sort of a story. So if we flip this around, we think about how could AI help us? What we would want to do is something we call semantic analysis of the websites, which is basically what a human does. A human goes in, and you can see on the left image, for instance, they're able to parse this website and block it off into semantically interesting pieces like a logo, a search bar, a menu item, some pictures, a coupon. And these have meanings and relationships, and a person knows this. They have a knowledge graph that helps them understand that. And then a person also, if you look at the middle diagram, they sort of have a raster scan attention mechanism that they pay to the website. This is called salience in computer vision. And this says, well, where should we focus? What's capturing the eye? What's most interesting? If we combine those two things together with our computer vision expertise, we can build richer detectors that can not only hopefully improve our ability to detect phishing and scams, but help us understand. Finally, you see on the right-hand side, this thing called HAR files. A HAR file stands for HTML archive, and it's sort of the transcript of what happens between your browser and a website when you go visit a website as things get rendered, all the scripts you download, all the images, et cetera. And if we combine that with the image processing, then we do exactly what humans do, which is we put together a case file, if you will, where we consider multiple different facets of information to make a decision. In machine learning, we call this multimodal classification. And this is where we should be aspiring in things like phishing and scams. The last use case that I'll go through, I want to talk about is misinformation. And misinformation is interesting because I think most people have an awareness that it's a problem. It's a problem for election security. It's a problem if you take it to the extreme, if you don't really know who you're interacting with, or if the content you're seeing is true, if you had to fact check everything and it was so expensive, who do you trust? How do you make decisions? So this is a really fundamental and existential issue that we have to deal with in the social good level across cybersecurity and other industries. The challenge here is that there's not really a well understood product market need. People want to be protected from misinformation, but misinformation, first of all, is a little bit on a sliding scale. Things that one person might consider biased or misinformation, for instance, unless it's an outright factual inaccuracy, might not be so egregious to someone else. Or if, for instance, if you look at a website with 10 claims that are factual and one's wrong and 9 are right and the conclusion is really right, is the whole site misinformation, or is just one piece misinformation? How do you process that? So I think the industry as a whole is trying to work on this. And what I'm showing here are two examples where we've sort of taken an educative and visualization approach to dealing with this. On the left, using some graph machine learning techniques and some seed misinformation, we're able to color different social network channels to describe the riskiness and the clustering of them toward misinformation. So for instance, we took a bunch of Telegram channels and some seed misinformation. We're able to show that lots of related and connected Telegram channels are misinformation that's biased in a particular way, which you can see here. And this is useful to try to help users be able to understand either sort of the focus area or potential for controversy in their social media online content platforms. On the right-hand side, I think there's a fundamental need for being able to how to alert users and explain the potential for misinformation without actually offending them or driving them away. So, the last thing you want to do is make a judgment call on your website that this is or is not misinformation, not without a lot of other context, because if you ever get it wrong on something that someone's really emotional about, they're just going to shut down and not ever use the product. And if you can't make comments on enough things so that it's interesting, then people aren't going to use it. So it's a really delicate balance for a usability point of view to get this right. This is an early prototype that some researchers that we work with at Georgia Tech were putting together to try to show something might be controversial because it's connected to other things which might be controversial, and you can deep dive and explore this. The actual tool itself is interactive, and you can imagine different variations of this. But the whole goal is that we want to be able to use AI to present something that's usable, that a user can interact with, that can help them make better decisions within their context about the type of information they consume. Lastly, on my part, I want to go ahead and close with future bets. This is something that I get asked about every year with budget renewal cycles, for instance. What's going to be interesting, or what could we invest in long term that could be really transformative? And I'll start with the one on the left, the generative AI. And this is a clip from an image from a company called Movio, which appeared in a TechCrunch article. You can go link to it. And the idea here is that this company is able to create marketing videos using a palette and some simple interactions. So imagine you could basically, in some version of these tools from somebody else, you could say, hey, create a marketing video that has someone that talks about 30 seconds. It does a classic Broadway pitch of my product and makes sure to give discounts to people in this region, et cetera. And boom, out pops this generative AI. Now, for us in security, the really cool aspects of this is the ability to automate and explore and investigate and deal with threats. So imagine for us, instead of a marketing video, an analyst could say, hey, I found this example file. Go find things that are like this, and make sure that you build a detector that's brand new, that detects these things, but has a low false positive rate, and give me the correlation with things I find on the web somewhere. Or you could use generative AI to create synthetic data, right? So for instance, I have one example of some ransomware, and I want to be able to detect it. So what would other examples of this family of ransomware look like? Can you create that for me? Or we could do simulation, which is like, I've got some users in a network and I've set up a whole infrastructure to protect them. But what happens if I start getting DDoS and ransomware and all kinds of crazy emails and stuff? Can we simulate this and play it out? I think these are the capabilities that are going to really be science fiction transformative for our industry. They're a little ways away. On the right-hand side, some lower hanging fruit that's here today. On the top, we talk about unsupervised or semi-supervised learning. And when we do this, what we're mentioning is techniques for dealing with the fact that we have few labels and not necessarily trustworthy labels. So in the computer vision industry, this is something they've made a lot of progress in. How can I take 100 images of cats and all of a sudden learn about billions of images of different cats, even things I haven't seen before, okay, that aren't in this image set? It's a really hard problem. And they've made a lot of progress in natural language processing computer vision in this, but we haven't made progress in the computer security space. So I think this is an area that's ripe for technology transfer that would be able to unlock all of this data that we have that we're not necessarily really fully exploit in cybersecurity protection. And the bottom, I'll just throw out NLP and large language modeling. So if you're not aware, over the last few years, 4 or 5 years, there's been this advancement we call large language modeling. The large means that the models are really big. They have, you see 540 billion parameters. That means that, these things are, gigabytes, multiple gigabytes of size. They're really big. And these are trained on enormous corpuses of text, and they can do some amazing things. You've probably seen examples of AI generated text. You basically play like a roulette game with it. You say, generate, 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 generate. Every time you click the generate button, you get a sample of text. And, you do this 5 or 10 times and you get one that looks really good. Looks like a human wrote it, okay? Now, in the AI industry, I think people acknowledge that this isn't really learning about language or storytelling necessarily, but because of the scope of data it's trained upon, it can provide some pretty unexpected and impressive results. So the first thing is, these things represent a security threat themselves. Right? So we have to be able to protect users against this, because this is a great way to potentially do social engineering or mining or leak data for privacy and things like that, introduce bias. But the second thing is, how can we turn this around and use this in security, either to provide interfaces for our users or to allow us to analyze and dissect the content of text, which is so much of a communication mechanism for people. And I think this is an interesting area that's very topical. Large language modeling is widespread right now, and I think we'll see some applications. There probably are some right now, but we'll see lots of applications of this over the next couple of years in cybersecurity. Okay, with that, I want to thank everybody, and I want to flip it over to Jaya, who will talk to us about some security things that she knows a lot about.
Hi, can you hear me?
Yes, we can hear you, Jaya.
Okay, so I'm just trying to share my screen. For some reason, I wasn't able to unmute or share. That's really odd. Let me just try it again. So let me just start off. Can you see my screen at the moment?
We can.
Lovely. Okay, great. So that's working. That's always good. So while we take it over from Andrew, what I want to talk about is actually the state of cybersecurity right now. So, you know, even if you're not paying tons of attention, we are living in a sort of arena where we can observe the first real actual foray or demonstration of what we're seeing in a sort of war games like function. Thankfully, the whole cyber war perspective has not delivered the way that we originally expected to. So for those of you that will remember, you know, we had seen numerous attacks on Ukrainian power grid systems by a group that was called Sandworm. We had seen significant threats to critical infrastructure, but we hadn't actually seen the sort of cyber war that we were expecting to see in Ukraine. So it kind of begs the question, you know, how can we actually get better from both a defensive perspective and maybe even to some extent an offensive perspective of getting better, not only recognizing the attack, but potentially conducting the attack? And will AI be one of those forces, you know, technology that's dual use that can be used for either good or bad? And one of the first kind of questions that was asked here was, I don't know if all of you remember the Cyber Grand Challenge that was run by DARPA, and it was really kind of setting up a simulation of attack and defense and trying to figure out if there were new strategies that would be somehow evolving out of systems that were set up to kind of try to attack each other and trying to defend at the same time. And what we saw was there were actually a few new strategies. And Andrew, you know, I'm going to ask him later to talk also a little bit about adversarial machine learning, because I do think this is one of those exciting ways to look at how can you actually influence some of those AI systems and what does that mean? That being said, although this was, you know, conducted in the simulation realm of DARPA, when it comes to do we see attackers using AI to actually attack others, and I say attackers in the broadest possible sense, from individual attackers to cyber criminals, as well as nation state actors, I can tell you that we don't actually see that. The exception is when you see a whole bunch of machine learning possibilities is really when you're looking at phishing attacks specifically, and you see the use of domain generating algorithms, which means that there are domains that are generated and they're done through some sort of ML tactic where it's really difficult for the defender to figure out all of the different domains that they would then subsequently need to shut down in order to get rid of the attack surface that was, you know, being used on the back of victims' infrastructure that were compromised. So other than these techniques, we're not seeing attackers at any large scale, you know, having the capability to democratize AI and then subsequently actually use it for a successful attack. If I would just go to the next slide, you know, the worry here is that at some point in time, it is going to be possible. And part of the reason that we are, from a defense perspective, worried is there is quite a bit of computing capacity that will be on offer in order to conduct more and more sophisticated attacks. Whether or not uses AI solely natively or from some type of malware and command and control perspective, right now, I would argue that the bigger advantage is in the hands of the defenders to make use of AI tactics in order to do structural security monitoring, really that threat detection that Andrew was talking about, and also to do certain level of decision making. But when it comes to the attacker, they haven't been able to utilize the same thing to conduct more sophisticated attacks, although the computing power is there because we are connecting all of these different vulnerable technologies that are traditionally analog, connecting them to each other in the Internet of Many Things, and then subsequently trying to make them, you know, smart. And what we're seeing is that this is actually a really effective vector to harvest for a very successful but almost stupid attack, which is just distributed denial of service. I'm not sure if those of you saw that recently. A few days ago, the European Parliament had declared Russia as a terrorist state, and as a response to that, we saw an attacking group called Killnet launch a distributed denial of service attack, a DDoS, against the European Parliament. And this is obviously not an advanced attack in and of itself, unfortunately, because the way to conduct such an attack is you go to Google, you type in boot or stressor, you find a whole bunch of DDoS services, and then subsequently you can use them to launch a successful attack against web services that don't have an anti-DDoS mechanism in place. And I think there are some real potential here, again, from a threat detection perspective, to try to figure out what are all these services doing that they have in common, so to be able to detect them at a quicker rate and also to be able to take them down. We shouldn't be able to find them over Google, and it shouldn't be as difficult as it currently is to defend against them. So we need a better recipe to kind of mitigate and eradicate distributed denial of service attacks. And it's not just going to be by adding capacity at the telecoms, because there is no telecom on earth that can actually defend against some of these large scale gigabit level, terabit level attacks. So if I just go to the next slide for a moment, the other big problem, and we've seen that for years now, actually for the last 3 or 4 years, we see that we have some significant issues with ransomware. And it's no longer a question of ransomware, it's ransom when, and we're not great even now at finding all of the different infrastructure that's being used to support ransomware globally. And where I think we could get better is not so much just, finding or detecting the ransomware, but also finding ways to get the decryption keys, and there also to share it more effectively. So there are projects, and these are traditional information security projects, where the security community tries to work together to limit kind of, what's the collateral damage by making decryption keys for ransomware tools. So ransomware, as you know, infects a machine, encrypts all of the data, and then you can't get to it unless you pay the attacker to get a decryption key. Now, what the security community has done is they've come together, the competitors actually came together and set up No More Ransom, where they then submitted all of these decryption keys, and then if you're lucky, when you are attacked, the type of ransomware you have has hopefully been decrypted by one of these entities. And we're also part of this at Avast, very proud to do that. But I really think that we're not doing enough to top the volume of attacks. So that's why when you take a look at the Europol report or international cybercrime statistics, ransomware is still the #1 most successful type of attack that's being exploited today. And there's something that I really want to say here, which is that we tend to be a little bit looking down on the attackers. We tend to think that there's a sort of superiority amongst the defenders because, there's a sort of moral right. Actually, this is shifting in the sense of what types of professionalism is actually there in this criminal community. So we're looking at, engineers that over the years, because initially, for example, if you remember just a decade ago, when you got a phishing mail or when you saw a phishing website, they were really poorly constructed. It was very easy to kind of distinguish that there really wasn't a Nigerian prince who was misspelling, the whole thing, that it was really a phony, bogus thing. And this, I think, is one of the areas where we could get better, which is that there are professional engineers. They have call center and service that are better than the defenders. They have all types of security skills, and they even, some of these groups are even, so responsible with the way they do security. They have bug bounty programs. So if there are vulnerabilities on their side, they want to be able to kind of have the security maturity to welcome the finder of the vulnerability and then subsequently fix it. We see them also deploying multi-stage attacks. So it's not just an issue of encrypting your device and then paying them to get the ransomware key. There's also like a sort of double tap attack where they hold your data hostage and will still threaten to release it publicly if you don't pay, again. So even if you say, no, it's good, I don't care if you encrypted it, I have a backup, they'll still threaten to make your data public or subsequent other tactics to kind of pressure you into actually paying. And there's this weird line in this sophistication, which makes us wonder, like, how are you getting this sophisticated? And there's this weird line where you see that there's much more blurriness when we used to classify individual attackers or cyber criminals or state-sponsored attackers. Those lines are getting really wavy, and we're seeing that these criminal groups are actually kind of state-sponsored, or at least not being handled by law enforcement to be eradicated or taken away or disrupting operations. And also that there are some of these gangs are really quite international. And we saw this, for example, when there was a group that was operating out of Russia called Conti, which was one of the largest ransomware operations that were there. When Conti openly went in support of the Russian war on Ukraine, not all of the members agreed with that. And actually, one of the members disagreed so much that they subsequently leaked all of the information about Conti, including the primary Bitcoin address. And then you see, I don't know if you can look at the upper right-hand corner, you'll see that was actually the Bitcoin wallet amount that they had earned through ransomware operations. And, there's a lot of very successful state actors that are supplying these gangs with the necessary fuel and funding in order to keep continuing. So I think that the whole notion that these cyber criminal gangs are not political, that's actually, at least currently, no longer true. So I think there are some needs for, looking at different types of remedies for addressing them. Also, like in this current conflict of the Ukrainian war, we thought there was going to be much more cyber criminal and much more cyber war-like activity. We thought we were going to see a flurry of new types of attacks, otherwise known as 0 days, which are brand new attack vectors that, the companies of the technologies of which the attack is applied to doesn't even know that it's possible. And what we're seeing is actually that's not quite the case. The initial attacks that we saw on Ukraine were not using any of these new attack modes. But what is worrying is globally, and you might have heard of Pegasus, etc., we see this black and white market for 0 days. During that DARPA Grand Challenge, one of the biggest solutions that came out of it was something called a fuzzer. And what a fuzzer does is it actually looks for variations of input, which would then generate different types of output that could be construed as a security failing or an unexpected finding, let me put it that way. And the idea is fuzzing tools are incredibly good at discovering new attack vectors or potentially 0 days. So thinking about using artificial intelligence tooling to do just this fuzzing approach, just to find more vulnerabilities that could be there in software so that you can have a much more robust and stable system, I think is already an added benefit. And what you see with this vulnerability market is that it is actually detrimental to everyone, because very often these 0 days are either bought or found by state actors or criminals. And then subsequently, they're to be used against hard targets. So we're doing all of this effort for a single hard target, but that one hard target, the 0 day that could be there could be like an Apple vulnerability, or a couple of days ago, there was some real interest around a vulnerability for Signal, which is an encryption communications tool that a lot of us use. And the organization in question was a Russian 0 day organization that was offering 1.5 million for finding a 0 day in Signal. And I think we need to really consider why and how we would support these markets, not only from a technological perspective, but also from a political one, and ultimately from the defensive perspective, see how we can eliminate, eradicate the finding of these 0 days while software evolves. So do a better job at this fuzzing and good software design and build practices so that we have fewer days to contend with. Fundamentally, when we take a look at it, 0 days aren't just being found there. They're also being found when the company themselves that may have found a vulnerability or an issue in their software, when they issue a patch, what you see is that there are folks looking for what was fixed, because we have a disturbing tendency not to apply patches, not to take the support and use it to make our systems and our networks robust. So as a result of which, even though companies are supplying us with updates and patches and guidelines and advice, we're not all taking it on board. And attackers know that we're slow to change. We're slow to adapt to new problems. So as a result of which, when those vulnerabilities come out, we see that the exploit developers are getting quicker and quicker at developing a new attack for that thing that was just fixed. And they know they have a huge population that's addressable because they haven't patched yet and they're not ready to go. And as long as they can up their cycles to not issue an exploit within, a few weeks, but in a few hours, then they still have a large surface that they can attack and then subsequently try to get some money from. So we need to get better as a community, whether or not we work in security or not, to actually take some of these security best practices and apply it to operations. And data presents a really significant problem in security to this day. And it happens in a couple of ways. First of all, we tend to kind of harvest it. The adagio, data was the new oil. So if that's the case, data is the new oil spill, or data breaches rather, are the new oil spill. And there's two problems with this that's really here. Like, companies don't always understand all of the data that they're collecting. They don't understand that data supply chain, not only the data they may then have themselves, but how that's subsequently populated to the rest of their vendors and their partners, etc. So sometimes these enormous data breaches, they have some common footprint when you look down the chain or up the food chain at who is actually involved during the attack. And here again, I think maybe this is yet again another detection tool, but it is such a concern that most organizations take incredibly long to know that the breach has even occurred. And this is not just from the perspective of exploitation, but even when that data is somehow floating in the wild, let's say that it's been put on some arbitrary pastebin site, even then it takes time for that organization, when it's already outside and exposed, even then to figure out that it's their data. So there's two parts of this. One is knowing that there's an actual breach, so a vulnerability in your systems that was exploited by an attacker. And the second part is when something was actually exfiltrated and then subsequently made public, having a shorter amount of lifespan, detecting that somewhere else. There needs to be a way to either compare hashes or partial hashes to know when there's critical information that is somewhere that it should not be. And we're not really great at that either, unfortunately. And I really contend that all of this, everything, all of the problems that we have in cybersecurity now that we need better solutions for, it's predominantly a financial problem. It's interesting for attackers to keep on attacking. They're not going anywhere. And I would argue that, this kind of leapfrogging potential that's there for attackers to go directly to AI, that potential is still there. That advantage is currently to the defenders, and we don't see any AI attacks, but I would argue that eventually over time, as long as it is democratized and is a cheap attack to conduct, it will still be worth it, because there's still a lot of money to be had actually doing cyber crime, because we see the rates increasing every time. The working from home has not helped it. We're actually increasing the costs again to companies who are trying to do defense and the cost of the breach to them. And we're also increasing the appetite of cyber criminals because it's just so profitable. So attackers will always go where the money is. We need to find a way to make the attack expensive to conduct so that it becomes almost economically unviable to keep doing the simplest attacks. Because why do they don't need AI at the moment? Because we give them vulnerabilities that are left unpatched. We give them easy to exploit phishing attacks and business email compromise. We're giving them a whole attack surface of willing ransomware victims who will happily pay, not want to disclose because they're embarrassed and don't want to have the regulatory fines or the public judgment. So while that attack surface is still available, I don't see them shifting to AI, but I think it's only a matter of time as we improve slowly but surely our defensive strategy and posture that this will become a concern. So I think we really need to think about how do we use AI for good before it gets used against us for bad. And I think there's really three parts to this. The first thing is, unfortunately, yes, it is another detector. We need right now to reduce the amount of time that it takes defenders to spot an attack. I can tell you that in the majority of security operations centers, they're still drowning in data. They're still drowning in this problem of efficacy, but with the false positives and looking at the right information, having like high value information that actually is really conclusive. And it's not even, this is just asking yet again for a human to make a decision. What would be great if there was automatic actions already executed and subsequently things that were kind of iffy or low on the efficacy scale to be then given to an analyst to then subsequently do. And as that gets trained better and better, that we get to this place where there's even more decision-making capacity for a well-trained AI. So the first things first is like better visibility and better knowledge and understanding of the attack surface. And I think there's a lot we can do with threat intelligence gathering and AI. And then subsequently, when we actually see stuff, limiting the amount of things that need analysis and then putting them directly over to this security capability space where we can be much, much quicker. Because I think the majority of attacks, the things that really hurt us is the inability to conduct rapid response. And that's really, if we can do one thing better, that will be it. Well, thank you so much.
Thank you, Jaya. Thank you so much. And thank you, Andrew, for that fascinating presentation. There's so many points that I want to hit on. Unfortunately, we only have 30 minutes for questions. So let's just launch it right now. I have some questions from the audience. I'd like to start with one that we received from Alev. She asks, cybersecurity may be enhanced by AI, but so can hacking and malware. This is an arms race. Who is leading in cybersecurity? How would you like to tackle that?
I think I posted a comment in NeuralNet on this, which I'll just mirror here, which is, first, I do think there's an arms race aspect to it, but it's not symmetric. The advantage that the attackers have, I think, is scale, and they only have to score once. But the advantage the defenders have is that we have some inside information that allows us to do sort of multi-factor telemetry correlation. So the, I guess, proprietary aspect of some of the data or systems that we have, multiple ones of these, makes it exponentially harder for it to be breached.
And in terms of, just to follow up on that, since these challenges are global, do you see any significant kind of geographical differences in terms of kind of who is leading in cybersecurity and using AI for cybersecurity? Jaya, do you have any opinions on that?
Well, I mean, I think there is, we tried to talk about this before, but I do think that like currently there is a little bit of a divide. So you do see this kind of stuff being reserved for more Western northern countries if we look on the traditional axes of divide. I do think though that like companies like Avast, where stuff is just built in, a lot of this stuff is happening in the back end and it's a sort of premium tool and that is globally distributed. I think that people are getting the benefits without necessarily directly getting it to them. I think what we could be doing better in the long run is have more of that back end capability built in, rather than having to try to build it out later from those different geographies. So if I would say we have an advantage, yes, it's the West with AI tooling and technology. But I think that that is a short-term, short-lived advantage when we go online, we're all using the same stuff all over the world. So I think that that's going to be a short-lived advantage.
Okay, great. And I wanted to ask you both, how reliant at this point do you think we have become, or will we become, on using AI methods for cybersecurity? And how do you see the involvement of human beings in the decision-making process? Because up until this point, there's been a lot of human intervention, let's say, in these types of threat detection, threat mitigation strategies.
You want to go first, Jaya?
Yeah, I have to say there's still a lot of human in most of the detection and the analysis and the majority of SOCs. And there are a few exceptions. There are security, like I don't want to name the company, but there are companies that'll say things to a security operations center. I have this amazing AI tool. All you need to do is send me all of your data. We'll upload it to my cloud over there. Trust me, it's fine, no problems. GDPR, SMEDPR. Just put it all over there. It's good. I'll analyze it for you and then tell you what the threats are. And this is a real problem This is a real issue that I think there's two parts of this. One is it tends to be a black box. You have no idea what they're looking at and what you're getting back. And the second is that it's not something that's being run distributedly on your network. It's something that you're very often handing off in some of these particular security operations cases. So I think there needs to be some level of confidence in that party that you would trust to do this for you. And then a second thing is a level of transparency, even when you trust them, a level of transparency to back it up.
Yeah, I think I would add a couple of things. First of all, there's the AI that we use as tooling and infrastructure enablement. And that, just imagine a software engineer doing coding. And he's got code completion in his editor, and he's got a recommender system when he goes to Stack Overflow to answer a question. And like, that impact of AI is huge. Then there's the AI that we embed into the actual protection products or engines. And I think that's fundamental in many cases. So imagine endpoint client protection, for instance. In that sense, the AI is not super sophisticated, but it's a way of sort of compressing the knowledge that the human experts have into something that can run in a distributed fashion at the endpoint. I think what's interesting to think about is whether we'll reach a critical point where security threat analysts or experts will rely on AI so fundamentally that they couldn't do their job without AI, like even for investigations, et cetera. And aside from the scaling argument, clearly AI could hopefully help them sift through and triage things. Aside from that, I'm not sure we're really there. And this is one of the challenges in the communities, right? Is people who are AI experts want to automate everything, and they look at the successes in computer vision in cars and stuff. But what we're missing is that security people who are trained professionals, they have enormous physics knowledge in their head that they're bringing to bear that doesn't get encoded in the traditional way that we develop AI. So I think it'll be an interesting thing to observe in the next couple of years, but definitely become more fundamental.
And I want to add, like, we're now, Andrew just tried to educate us that it's not all lump sum AI. It's not one thing, it's all these different flavors and all these different capabilities. And just to be fair, like when you look at the average analyst now, they're overwhelmed. There's a ton of data coming at them. Most of it is not even useful. They have to kind of select the majority of the alerts that are coming to them and make smart filter choices, et cetera. So I think there are so many different types of tactics you could use along the way, from trying to be better at spotting vulnerabilities to actually having some sort of assistant to help you improve your ability to actually look at stuff that matters, to then finally, having some actual correlation between a potential attack and incredibly quick response. So I think there's so many different things that we could be asking from, like, this blankety version of AI for some very specific niche tooling for each of those areas.
I want to add one more thing, which is my favorite application of AI is about usability. Basically taking someone and making them a superhero, right? Like an Iron Man. And in particular, like if you look at the workflow of a threat analyst or somebody like that, it's an enormous amount of work to bring together the case file and process. Wouldn't it be amazing if we could just encode that and have the AI assistant just give it to you? Because what people are really good at are making decisions. And what the AI is really good at is statistical pattern mining at the edges. And one of the things that we have to remember in security that separates us from many other industries that are flourishing with AI is we have a different cost function. It's not okay to protect against nuclear threats and be 99.9% right. You got to be 99.99. You have to be 100% right. And in other industries, like if I'm going shopping, I ask for a red book, I get a magenta book. Who cares? I'll try it, right? And this is something that we forget about in the security space that I think is important.
Actually, yeah. And if I could just feed off of that for 1 second, and I was hoping we'd talk about this, Andrew, but what I would really love is, like, for the SOC analyst, I'd love Jarvis, right? Iron Man related. I want Jarvis, but then I want Jarvis to present the information like a sort of Tinder, where there's like a there's like a sort of population of the threat. There's all this other stuff, and then you can kind of swipe left or right. Is it bad or good? Kind of.
Yeah. That's a great idea.
That's awesome. So Andrew, you're just speaking to what you're saying, that the stakes really couldn't be higher. And as you mentioned in your talk, efficacy is key. In order to operate in this business, you have to be completely efficacious. I wanted to ask you then also, is there any sort of a role here in when you talk about transparency and efficacy? Is there a trade-off in terms of the inability, let's say, to explain how some of these decisions will be taken? Do we need to go into these, long explanations of how a black box has, with all these different decision trees and all these types of things, how they've actually reached a decision? Or is that something that the end user, let's say, at the end of the day, isn't that concerned about?
Well, I think there definitely needs to be some guardrails in place for that. You can see, historically, you could look at cases. We could talk about famous AI type systems. One that comes to mind is Microsoft A, or recently Facebook just open source Galactica. And inevitably, these things are released with good intentions and with the philosophy that the data drives it. We don't have to have, these guardrails, for instance, and people find bad uses for this kind of stuff. So the way to get around this, or help people at least understand when they experience it, is to have some explanation and interpretation. And that's just for good adoption and good usage. And then there's a second level, which is we talk about responsible AI, which is a lot of times people are using these to make decisions where you care about fairness and privacy and bias, and these are important for a business function or personal function. And without an explanation, or interpretability, what are you going to do with that, right? And then the last one is, even just for people who are experts who use this, even like me, when I look at an AI system, it's so much faster for me to have trust and be able to troubleshoot potential problems or prioritize my usage if I have some understanding. That's the way we do things as people. We reason epistemically, right? I know you, so I trust you. I know the way you think. The reason I know the way you think is because you explain things. We need to mirror this in our AI applications as well.
Right. And AI obviously is only as good as the data that is being used to train it. So I wanted to ask you a kind of a simple question. How do you know what data to use to train these types of models? And is there a way to ensure that the models are able to detect unknown or emerging threats for which models haven't yet been built?
Well, I think how you know what data, it's good use case development, and it's a little bit of trial and error, right? It's experimentation. But I think, framing the problem correctly and really understanding what success and failure could look like, and thinking out of the box, just stretch it a little bit. What are some of the unknowns that can happen? And then once you get into that mindset, you can sort of anticipate what some of the data candidates would be, and you go through the experimentation process to trial and error to develop something. And then the second part of it, all AI systems should have watchdogs. Could you do it? Probably. Maybe not always, but you should at least try. And I don't think people try enough. Like, we really don't. Imagine software engineering. Software engineering. I guess when I first started adopting it, unit tests were a really big thing. And basically, you write little tests. In fact, the whole philosophy was you write a test for some function before you write the function. And then it makes sure that it works, and you get a little green bar, and you want to see green across the board. And so it's very test driven, quality driven. We don't have anything like that with AI. In fact, I don't know of many people. We don't test data, and we don't test the models in that way. What we test for is what I call happy path. For this data set example, to prove its feature for the product, does it do the thing I want it to do? Not what else does it do that I don't want it to do? Not what should it do, et cetera. Just does it do the happy path? So I think that's under, a lot of people are aware of this, and there's a lot of forward-leaning legislation happening and being considered in the EU, for instance, which I think will help deal with this, right? Sort of the legislation for what makes AI acceptable and how you test it.
Okay. Great. Thank you so much for that reply. I wanted to ask you a question from the audience, from Alev again. How would you say that quantum technology might change this landscape? Any takers?
You want to take it, Jaya?
Yeah, well, I'm wondering if I understand the question. I mean, there's two parts to this, right? There's obviously the quantum threat to cybersecurity, and then there's the potential for using AI ML together with quantum computing at some level. And so there really is two parts to this. So let me take the cybersecurity part for a second. I think, we've discussed this ad nauseum, in my opinion, for what quantum computing will mean for cybersecurity, because it's one of the initial use cases, if you will, for what will you do with a quantum computer? Oh, well, when it's, viable enough, you'll use it for actually some strategic purpose to try to decipher information based on the current algorithms that will be broken by a quantum computer that we're using all over the planet for cryptography. So I think that that is a significant change. Do I think that there are some solutions here from AI? I don't see a direct link, but I do think that, you know, when it comes to defenses and evolution of our technology, because we're really not good at evolving at all. I mean, again, like my favorite example of where's IPv6, you know, we have it as a standard for a very long time, but we haven't adopted it globally, even after. So just like that, I think that really for the quantum threat, we need to get better at adopting new algorithms. That's the first and foremost priority from a cybersecurity perspective. But do you want to take it from a machine learning and quantum thing, Andrew?
Yeah, I guess I have just two kind of high level comments. First of all, it's a nascent area of very active research on what can you do, what algorithms can achieve speed up. You know, there are a few core algorithms that power machine learning, linear algebra operations like matrix multiplication, stochastic gradient descent, things like that. So can those realize speed ups, which would be enormous? And for me, some of the advantage would be a social good for energy, right? You know, we spend so much energy retraining models in these data centers over and over and over and over again. But the second part of it, I think, is you know, what new algorithms could be invented, right, which couldn't exist right now. And so this is emerging. My perspective on it is it feels a little fusion-esque. It's always just a little bit on the horizon. I think it's definitely on the horizon, but I don't really know what the timeline would be. And when it does happen, anything like this is disruptive and a change point. So there will be amazing new great things that we can capitalize on, but there'll also be a whole host of new risks and exploits and things that'll happen. You know, I'm not sure what there'll be in machine learning, but I guess we'll find out over the next few years, right?
We'll definitely adapt, and also it will enable the things that we're doing today. Great, thank you so much, both of you. Switching gears, have a question from Frederick. He asks, have you seen any cases of hacking wearables or AI-powered health applications that ended up causing physical harm? And is this something that we should worry about in the future? Anybody?
Jaya, right. I think I answered this one in the forum also.
Did, okay.
But I'll just mirror it. Basically, anecdotally, I heard at an insider conference, so I don't know if it's true, something that reminded me of the movie The Net with Sandra Bullock, where basically a floor on a hospital was cleverly infiltrated and hacked, which altered patient information. But I don't know that it caused physical harm because, you know, I think the punchline there was the doctors recognized the dissonance between what a patient was presenting and talking about there and what they were seeing in the charts, for instance. But certainly it would be scary to think about, you know, your insulin pump or your pacemaker or things like that being hacked. Yeah, I just don't know of any examples off the top that I've heard of.
Good news.
That's good news, yeah.
So far, all right. Jay, are you back with us? I think you were frozen for a bit there. I don't know if you were speaking.
Oh. You know, it's the World Cup, and I have children downstairs just watching it and sucking literally the bandwidth dry. So I apologize.
No problem at all. No problem at all.
Yeah.
So I wanted to get back to the content of your presentation, a couple of things that really stood out to me. One thing, Andrew, you brought up large language models and AI generated text. You know, there's a lot of hype around these models given their ability to generate convincing text, you know, and mostly talking about, you know, nefarious uses. But you gave kind of a hint that they could be used for good. Do you have some specific examples of what that might look like?
Well, yeah, I mean, the inverse problem of generating text is being able to analyze it. So you can, like, say an example, I don't know that this one exists, but I know that some people have worked on it. You can look at, you know, CVEs and mine those for patterns of exploits or threats and summarize that, right? So you can analyze the text and then you can generate a short summary that might be useful to help accelerate an analyst who's researching exploits or something like that. certainly in the cases when you're looking at, cyberbullying or sextortion or abusive language content, things like that, you would have as part of that pipeline a large language model to try to understand the language. But it's still a really complicated problem, even for people, right? You could imagine that there's a lot of variance in the decisions on whether this is good or bad. So, yeah.
And building off of that, also kind of what you're speaking about, disinformation. Thanks for bringing that up. The examples that you gave were really interesting. Now, I want to ask you, what level of maturity are we at in terms of the methods that you described, and what role would you see AI kind of playing in mitigating the threat of disinformation?
Mitigating, I don't know that we're actively mitigating. Informing, if that's a form of mitigation, maybe. But I've reviewed some techniques that are they're reasonably advanced that detect propaganda spread by nation states. They're pretty good. Again, I kind of want to go back to something that I think Jaya mentioned, which is the bar to state-of-the-art AI for attackers. They don't have to do state-of-the-art AI. They have much less sophisticated techniques. So for right now, the response doesn't have to be ultra state-of-the-art either. It just has to be ahead of the attackers. And so I think we're a little bit ahead in detecting the spread, especially in focused use cases that we want for potentially like nation state disinformation or high profile individual fraud in certain channels or particular topics, election fraud, things like that. But it's unclear how fast that could change, because I think it's mostly like a consequence of the emergence of this cat and mouse game, and the dynamic hasn't played out all the way. So.
Right. And kind of related to that, building off of what Jai was saying, that, basically we don't have to go to these very sophisticated types of things when, we're offering vulnerabilities for them to take advantage of as it is right now. So does that mean the threat of deepfakes are a hype, let's say? Or are deepfakes actually something that we should be afraid of?
I guess I'm kind of value neutral on afraid. I think, I guess if you say deepfake, you mean the application of generative AI to manipulate someone.
Yes,
Okay.
And not just in the context of text, but obviously.
And so that's bad. Well, it's here, and you can't defeat it with AI. I don't think. My view is if I'm being presented a video in a Zoom feed and it's deepfake on the originator side, I will never decisively win that cat and mouse game on the receiver side just by looking at the video. And so when I see a problem like this that looks like a stalemate or even something bad, I ask myself, well, what other auxiliary approaches, how can we change the business process, the business model, right? How can we do this? Like, so for instance, if we move to a world where, Zoom, you have, in the Zoom conference, a real human liveness detector, now that changed the dynamic again. And again, it's going to be a cat and mouse game, but I think that's kind of the solutions we have to look for if we really want to stop deepfakes. Otherwise, it seems really neck and neck, especially like even our host, Anna, right? The virtual agent was pretty good. If you didn't know to look for it, you might not realize it was an agent. So. Right.
So if AI isn't the key to defeating nefarious AI, what will the key actually be? Don't expect an answer for that. It's just a reflection.
Well, it's not AI. It's more like this. Let's see. I think there's a story in India where they had a cobra problem and they wanted to stop the cobra infestations. And so they put a bounty on the head of a dead cobra. And what they found was that encouraged the breeding of cobras because they would breed them and kill them. And so I think the cleverness here is still going to involve AI, but I think you have to change the vector that you're approaching it. It's not the obvious AI versus AI. It's AI doing something a little different. Like maybe you track down deepfake actors, or maybe you have AI and identity watermarking technologies, or something like this. You have to approach it from a higher level. The AI is just going to be a tool that you're probably going to have to use, but you're going to solve it using more than just AI.
Got it. Okay. And I wanted to ask you, Jaya, machine learning, domain generating algorithms, these things that you were talking about in your presentation, you were saying kind of that other than this, attackers aren't really leveraging sophisticated AI successfully, but it also sounds like we're kind of not out of the woods. What do you think we should be on the lookout for? Kind of what are the emerging threats that we maybe haven't seen yet or we're starting to see?
Yeah, so I think, look, first of all, already on this idea that you just asked about the deep fake use, and you mentioned that earlier as well, I don't think you're going to see a lot of C-level execs saying, my finance department was actually duped, not by me, but by, like it sounds like when we say the words, when a company gets hacked because they haven't done the appropriate level of cybersecurity defense, then this sophisticated attacker attacked us. It's a sort of plausible deniability. So I think there's two things here. I think first and foremost, the real hard work, the not sexy hard work is just getting your defenses up in order. And that means that whether it's a regular good old phishing attack and just a horrible business email compromise email that gets sent, or phishing, or whatever type of attack it is, that we know that there should be a alternative mechanism to validating and verifying any claim that asks you to transfer money to the Cayman Islands. Like, let's just start there. If we start there, that's a good spot. So a verifiable claim for that kind of stuff, I think that's really something that is required, even from the BEC perspective, but also for a deep fake. And then what I do think we need to be on the lookout for is this democratization of AI as an attack tool. I don't believe that we will find it unless we're actually looking for it. So there's a little bit of a sort of delta between how we look for it effectively in the wild and the time of use. So it probably will be that we will be catching up. So it may be used already, that we wouldn't see it for 6 months to a year, and then subsequently we'll know how to look for it, and then maybe we'll find it.
You guys, are you familiar with the training data leakage issues with large language models?
Yes.
So a large language model trained on tons and tons of text. There was one I saw someone on LinkedIn last night posting that their code, when they prompt a large language model, GitHub Copilot, that it reproduced their copyrighted code that was in a private repository. Okay. And I think maybe this is one of the areas I'm worried about, which is the foresight in privacy and data protection, that today and for the next 3 years, we seem secure, but it's there forever. It's an indelible footprint. And the strategy, if I was a criminal, and I think this is a strategy, is, steal and hoard now, figure out what to do with it later. With enough information, and you can imagine advances in AI and all the all the information in the world that I want, I could create virtual models of you. I could guess your passwords. Already cases like this exist today. So I think the emerging threat that we have to think about is this unintended consequence of AI-ifying everything. And the thing about AI-ifying is it's so endemic to the business model. Every business realizes a user benefit, whether it's a cost savings on the back end through automation or a feature that a user likes. So ultimately, things a user does touches these AI, so the AI is exposed. There's some path to attack it and attack the data that it's built on. And I think that's what we have to safeguard, really, as our AI and data systems. So
yeah, that's frightening also, because that's not something that can be regulated. That lies within each and every company. So yeah. It's terrifying, actually.
Just to be clear, this is not just an AI only thing, because you'll see that every time that there's breach information, there are people that are just getting the dump. Like, let's say it's on Pastebin or somewhere else, someone will get the dump, harvest it. And there are actually people who've saved, tons of information, like terabytes of information from all different types of different data breaches. And there are a lot of companies that, and it has happened in the past, where they didn't know that they were breached until they found their information in a breach database. This is certainly true for private individuals. So I think that longevity of data is something that's absolutely not something that we should underestimate. And still an area where I think here, actually, we could do some good by just helping create that linkage between what's already out there and then notification for that company.
Yeah, it sounds like it's there's a piece of this that also is educating, right? And you can be a large company and not really understand the ins and outs of data privacy. You should, but not everybody's perfect, right? So I wanted to ask another question from the audience. I want to make sure, though, Andrew, that you hadn't answered this before, that someone hadn't answered it already. What about the impact of quantum cryptography and quantum key distribution?
I didn't answer that. I think Jaya might have something to say about it, but I'm reminded of the quote, like from some movie I saw, maybe this is a real quote: "The greatest trick the devil ever played was convincing people he didn't exist." And what I'm thinking about here is, quantum cryptography, either we have quantum computers that can break cryptography or not. And that's when I think about it at night, like in my science fiction hat, like, where are we in this, or when will it happen, right? What does that unfolding look like? The actual mechanics of the cryptography and key distribution, to me, it seems like there'll be a point where it'll happen and you can break it. And if you can break it, you can go pretty quickly. And I don't know how we would possibly detect or stop that. So, but Jaya, we talked about this briefly. You had some thoughts on this too, right?
Yeah, so full disclosure, I'm the vice chair of the European Quantum Flagship. And so this is something that we actually monitor really closely. And I also work with ETSI on the post-quantum cryptographic algorithms that are coming out of NIST, making sure that they have like a wide fertile area of adoption, for Europe. So the first things first, we have some standards from NIST, so everyone can already play with it. In terms of quantum key distribution, it's something that we have longer, but I think that in order for it to actually be adopted, you need to have it in some sort of underlying transmission technology. So in order for it to get democratized, the quantum key distribution stuff, you need to have it in a sort of quantum internet that it's delivered to everyone, because I don't think we're going to be setting up QKD links. That being said, if it's like a bare bones that everyone has it, cool. And on top of that, we do post-quantum cryptographic algorithms. That's that evolution again. That's the thing that we're so bad at again. So we really need to get better understanding the threat, which is for, the way that Andrew and I talk about it is it's like this existential thing that you'll never know, because the person who has this opportunity will not make it public. So if you can decrypt everyone's communications, you're not going to tell everyone about it. You're going to let everyone use their old cryptography and then keep it quiet as long as possible so you can capture now, decrypt later. So we just need to get better at proactively defending ourselves before we think to attack.
Right. Okay, so I wanted to ask you it sounds like AI has a lot of different capabilities within cybersecurity. I wanted to ask you specifically, what is it enabling that we weren't able to do without it before in cybersecurity? Where is kind of the biggest jump that AI has given us in terms of this?
I mean, I think there's a lot of things. I guess since I'm in the industry, it's maybe hard for me to single out the one biggest, but this is a couple of examples. Certainly detection. And so better detectors, and that means better scale and velocity too. So you can detect across more potential threat surfaces faster. New types of detections. I think graph machine learning is really popular in the last couple of years, and being able to correlate things that have relational structure. There have been a lot of breakthroughs. I know even within our company, we've been able to use this to greatly enhance some detection products. The usability part that I talk about, like even it's very popular in a class of security products to have what we call active learning, which is a human in the loop, to help accelerate how things work. And that's very valuable and useful, because remember, humans aren't going to go away. Humans make decisions, and humans assign the utility function that we use to evaluate the outputs that we achieve from our systems. You can't replace those exactly, but machines can do the crunching and the statistics of things. So yeah, is there a killer new cyber threat that the AI protects against? I don't know. I don't know if I could comment on it if there was. So, Jay, maybe you have
Yeah,
some.
I'm trying to think. The thing is, I think the hardest thing that we have to do is to link threat actors to each other, to their campaigns. It's the most difficult thing, like trying to, in that myriad. I thought it was a really good visualization around the disinformation. Imagine that we could do that, that we could say, oh, wait, here's some code reuse, here's some source information, here's some actor type, and if we got better at doing that in a global perspective, I think that would be a sort of killer demand, because we would be able to trace the adjacencies between these different actors.
Mm-hmm. Build out these networks to understand them better. Yeah, that's great.
And stop them. Yeah.
Yeah, and stop them. So want to talk about happy things, since this is AI for Good, I wanted to ask you, what's the biggest cybersecurity and AI success story you've either heard about or been involved in?
Ooh. I think for me, it's because, you know, we're a little slow in cybersecurity and I'm such an AI centric person. It's AI and there's a couple. The progress on the self-driving cars, even though I was kind of joking a little bit, I think that's amazing because that's globally transformative. This is $1 trillion industry transformative. This is geopolitical disruption transformative. And it may take another 5 or 10 or 20 years, but it's kind of interesting. Protein folding for drug discovery. I mean, this is fascinating. This has the idea to really bring in personalized medicine, which can be used to democratically address the inequities in healthcare across the world and also just generally be kind, right? And help people who are suffering. Those are two big ones for me. And then creatively, the generative AI, being able to, you know, like even starting with the large language model to generate text, which I write as a hobby, and it can't write a story, but it can give me ideas, right? It can help, or, you know, creating special effects for movies or creating videos that can be learning tools and things. This is like, or even art, right? This is an amazing creative opportunity. I gave an interview when I first joined Avast internally, where I talked about AI, and one of the things that I found myself saying and surprised by was AI has helped me understand more about humanity than without AI, because so much of AI is a quest to mimic or extend the properties of, you know, good humanity. That it's really been a great reflection tool, a great mirror. And so in the creativity vector, I especially like that because we understand more about art and content and aesthetics. So
that's right. We have a human imprint of ourselves on everything that we do in AI. Jaya, do you have any nice stories?
I wish I could say we were more successful in cybersecurity, but we still kind of suck in terms of actually solving some of these bigger crises. What I do think is incredibly encouraging, though, and then to borrow on that human aspect perspective, there was a director at Europol who said it's amazing what we can accomplish when no one cares who gets credit. And you know, this idea of cooperating between different law enforcement agencies and trying to actually have this joint purpose and goal, that is something that I think every time we take down some of these groups is a success story. So every time that like people are cooperating, they don't care at the end of the day anything except getting that job done, I think that we can talk about genuine success.
I totally agree that triangulation between industry and science and law enforcement is something that isn't always achieved, but when it does happen, it's an amazing thing to see. Another question from the audience. Can AI help us attribute attacks better? And what else can help, if anything, attribute attacks better?
Well, I know that's true because we had one story when I was at Symantec that we would talk about where we had an attack which had some bad consequences, and all we had was the name of a file. It was an innocuous file like mshost.exe.
Mm-hmm.
And that sprung an investigation where we spidered out across the graph of all interconnections. And normally this spidering is combinatorially explosive. People can't do this. This is where AI helps, because it helps you prioritize and find these little threads to become a better detective and have less dead ends. And we were able to actually track this down to the group that generated this file and engage law enforcement to take them down and remediate the situation. So I know it can help. Yeah, maybe Jay, you have even better war stories since
I was thinking about some of the stuff that's happening, you know, even now at Avast, Andrew, like with Cadet, you know, with doing the campaign detection stuff. I think that's really interesting stuff. And you're just looking at, okay, at this point, you know, last year, how many attacks did we see of this kind in this area? And I think just that alone already helps analysts do like the reverse engineering and the threat analysis and do their write-ups in a much more efficient way. So I think if we can keep doing stuff like that, we're on the right track. So it can be an incredibly explosive force for good. We just need to know how to harness it and use it more frequently.
I think there's a nice twist here too. We were talking about how criminals could have as a strategy for business model hoarding data and exploiting it later.
Mm-hmm.
But the inverse is true also for just imagine like DNA testing in criminology. right? You have samples, that's data you've hoarded from crime scenes. And then 20 years later, when you have the technology, you're able to do the attribution analysis, right? And I think the same thing can happen with the records of activity digitally, that we keep. So I think the ability of AI to allow us to go deeper into this iceberg of unexamined data also has the potential to help us with this attribution, improving it.
That's great. You're giving me hope. Lots of scary stuff we're talking about. That's actually a really great way to kind of round out the conversation. That there's a lot of that still can be done for good. That's great. And I wanted to just ask our final question. We've been talking a lot about different types of technologies and methods, but I wanted to kind of bring it down a little bit to the regular user level and ask you, what should a regular technology user, just a regular user of their smartphone or their laptop, understand about AI's role in cybersecurity? What do you think they need to know about what AI is doing to enable cybersecurity?
Wow, that's a good question.
That's a really good question. I would have to say that, again, this ability to trust but verify, there's this sort of, we used to say in cybersecurity for a very long time, like cryptography isn't taking off because Johnny can't encrypt, it's made too complex for having this sort of massive adoption. And I think that AI doesn't have to have the same type of encumbrance, that it can have a wider adoption because it's built in a back end rather than very close to the edge of the user who may be getting the benefits of it without necessarily using it themselves. But I do think that as people, and I see this more and more today, unfortunately, people begin to mistrust technology because they don't understand it, or they're not able, there's no interface for them to be able to see it in a more transparent way. So I think if we could kind of afford them that, a certain level of understandable transparency, I think it would create a lot of greater appetite for us to be able to help people.
I would say people should be less afraid. Even though we talk about all of the exciting new risks that AI can bring, the reality is that by building systems with AI, we actually do a much better job of proactively addressing a lot of these risks. And so they're baseline more protected. And then I think if you roll back the clock, 5 years or something when AI wasn't as popular. And then the only other thing I would have as a piece of advice to go with it too, which is as our digital lives become more complex and we do more task switching, right? I go to different apps or entertainment or content sources, et cetera, different devices, just being mindful, because it's the context switch where we lose attention and we stop our common sense and we're subject more to the social engineering aspects, right? Or just giving a second thought. So that's what I advise people to do too, is just be a little more cautious about that, but also don't be so afraid. I mean, it's actually more good than bad. So.
Wonderful. That's a great way to wrap this up. Thank you so much, Jaya and Andrew, for the fascinating conversation. Really appreciate your time. And love to see you here again on AI for Good.
Bye-bye.
Bye-bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.